Hello my dear students, this is Akash SD and welcome to the ESD physics classes. So students, in this class we are going to learn about the electric dipole and the electric field at the different points of electric dipole, and this is going to be the part 6 of the electrostatics. Okay students, so let's start the video. So first we are going to learn about the electric dipole. Is it electric dipole? It is very common in chemistry also. Is it? I think so. You have some basic idea, but now we will see here in a mathematical form. Okay. So see here, please, here a system of two equal and opposite charges separated by a small distance is called electric dipole here. So see here, students, here I am just going to draw here how to represent the electric dipole here. So here I have taken here two charges. As you can see here, the charges should be same magnitude and opposite. That means here minus q and here plus q here. Okay, and the center of the dipole for the derivation purpose and all we will take here. And the distance between the two charges will be how much? Small d. Here just for the representation purpose, here it is looking d somewhat bigger, but normally this d is used to be the very small. That's why here we are writing small distance. Two charges are separated by a small distance. Okay, so this is just a representation. After that, this dipole is having some characteristics property also. Is it? How to represent the property of this in a mathematical form? For that we have one physical quantity, and the name of the physical quantity is the dipole moment. So kindly see here, students, every dipole has a characteristic property called dipole moment. After that, what is the dipole moment? It is defined as the product of magnitude of either charge and the separation between them. Is it, students? So if I want to write here the dipole moment in a mathematically, how we will do here? But before starting the dipole moment mathematically, remember that one thing, this dipole moment is a vector quantity and it is having one direction also. And can you guess please what is the direction of the dipole moment? The direction of the dipole moment is always from minus q to plus q charge in this direction. Now in this direction, dipole moment direction is there. I will write here p cap. Okay students, so let's see here, please, here some important points. What are the important points are there? First one, as I told that dipole moment is a vector quantity directed from where to where? Negative to the positive charge here. Second one, students, SI unit. But before starting the SI unit, I have to prove what is the dipole moment here. Okay students, so first let's see what is the dipole moment. So as I told, students, here see please, here I have taken here the charge minus q and here charge water plus q, and this is the center of the dipole O. Normally what happens that here distance between the dipole is d, but whenever we are doing the derivation, that time what will happen? We will use the center to charge distances, and this distance will be a and this distance will be also here. And by seeing the diagram you can see very well what is this, d equal to 2a. Is it? So now according to the dipole moment definition, just please recall it. Dipole moment is what? Product of either of the charges and the distance between them. That means if I want to write the dipole moment, product of either of the charges, I have taken only one charge q, only magnitude, and the distance between them. Even we can write qd also, or we can write q into 2a also, and the thing is okay. But remember that when we are doing the numericals, that time we will use q into d, and when we are doing the derivation, that time we will use q into 2a, because some confusion comes because of this two time. That's why to be safe for the numerical we will use qd here. Now students, you know very well dipole moment is the which quantity? Vector quantity here. Is it? So if I write it in a vector form, which form, students? Vector form. So see here please, this p equal to, I am writing 2aq, this is the magnitude. The moment I will multiply here with the unit vector. What is the unit vector here? As I told, p cap. In which direction? This direction, from minus q to plus q charge. Is it? That means here we have to put the vector sign here. This is the dipole moment representation in a vector form. Okay, now after that let's go to the other topic. See here please, SI unit here, SI unit. Now, so what is the SI unit, students? As you know very well, the dipole moment, what is there? Q into d. So for charge means coulomb, distance means meter. So we'll write here SI unit coulomb meter. Similarly, dimensional formula. What is the dimensional formula? For charge dimensional formula AT, and for length meter, that means you'll use here ATL. After that, if we talk about practical unit, like for the speed also, normal unit is a meter per second, but normally the practical unit of the speed is kilometer per hour, that we use in our vehicles and all that. Similarly for dipole also some practical units are there. And what is the practical unit? D by. But how to just explain this D by, is it? So for that, please remember that what is this? Two equal and opposite point charges, each having charge how much? 10 to the power minus 10 Franklin, and separated by how much distance? 1 angstrom distance. Then it will be called water, then it will be called the D by here. Okay, so just let me represent again what we are going to learn. We are going to learn the D by here. D by 1 D by. Now what is 1 D by here? So see here please, again I am taking here. Now, and here how much charge is there? Minus q. Here how much charge is there? Plus q. And the distance how much? I am doing the mathematical calculation, that means here I will take care of the d. You know very well for the d by what is the value of q? Q is 10 to the power minus 10 Franklin, is it? Now we have to convert this Franklin into the SI unit, because we are going to find out the relation between d by and the coulomb meter here. So I hope so you know very well. If I write the charge unit in a SI and the CGS, so what is the relation? You know very well. 1 coulomb is equal to 3 into 10 to the power 9 ESU, stat coulomb, or electrostatic unit of the charge. This itself is only called Franklin. So 3 into 10 to the power 9 Franklin. Okay. Now, so if I write here what is the 1 Franklin? 1 Franklin means here it will come here 1 by 3 into 10 to the power 9 coulomb. Is it? Now we will put here. So remember that here this will come here 10 to the power minus 10 by 3 into 10 to the power 9 coulomb here. Okay, so it will come here 1 by 3 into 10 to the power minus 19 coulomb. Okay, now after that distance, this distance will be how much here? This distance is used to be 1 angstrom. Angstrom means how many meter? 10 to the power minus 10 meter, is it? So now we have got the charge, magnitude of the charge, and we have got the distance. So now if I write here the dipole moment, very easy, P equal to Q into D. Now, and now just put the values now here. This value here, what this will come here? 1 by 3 into 10 to the power minus 19, and here 10 to the power minus 10. Even I can write here like this, 10 by 3 into 10 to the power minus 13. Simple mathematics. So we can write here 3.33 into 10 to the power minus 30 coulomb meter. This is the relation between d by and the coulomb meter. Very easy. Now please remember the relation, they may ask in an exam. So after that students, we have covered all these things. All these things we have covered. Dimensional formula, practical unit, d by and all that. Now what we are going to do? We are going to calculate the electric field due to the dipole, because you know question will come, net charge on the dipole how much? 1 is minus q, 1 is plus q. Net charge on the dipole how much? 0. But still the dipole is having its own electric field also. Why the electric field is there? Because these two charges are not at the same point. They are separated by some distance. Very small distance is there, but still some distance is there, yes or no? So because of that smaller distance only, what is there? This dipole is having its own electric field also. Okay, so we are going to see the 3 cases of the electric field due to a dipole. First we will see due to the dipole, after that we will go for the short dipole. So I hope so now you are understanding the topic very well, and even this derivation will come in exam also, in a board exam, and question will come in a NEET and JEE exam also. Please see it very properly. So case 1. What is the case 1? At a point on the axis of short dipole. So on the axis for the normal dipole, then we will take it to the short dipole. So here also what we can take here? Here I have taken the charge minus q. Here I have taken the charge plus q here. Let's say decrease it somewhat. Now after that, this is the center of the dipole is there. Now we have to take one observation point. Observation point is where? On the axis, like this here. See here please here. This is the observation point A on the axis, is it? So distance from center of the dipole to the observation point is r. Center to observation point r. And we know very well this distance is how much? this distance is A, this distance is also A, is it? So now electric field at point A will be due to how many charges? Two charges, one due to minus Q charge and one due to plus Q charge. Now if we see one by one, first one, now the electric field at point A due to plus Q charge. So you know very well the plus Q charge is near to the observation point, so electric field will be stronger, and in which direction? Away from the positive charge. That means like this here, this is here, this one we can write here E plus Q here, E plus Q, is it? So now we will write down electric field at point A due to plus Q charge is given by E plus Q is equal to 1 by 4 pi epsilon naught into magnitude of the charge and distance between charge and the point A. So see here, please, here this distance how much here? Let me just change the color actually. So this distance how much here? This distance will be R minus A. So we'll write here R minus A whole square magnitude. Now if I want to convert into the vector form, then what we have to do? We have to multiply with the unit vector, and you know very well unit vector in which direction? This direction, P cap, from minus Q to plus Q charge. So the moment I will multiply with the P cap, here I have to put the vector sign, is it? Now after that, again we'll write in a note like this: electric field at point A due to charge minus Q is given by, we'll write here E minus Q is equal to again 1 by 4 pi epsilon naught into only magnitude of the charge. Okay, so Q by, now the distance between minus Q and this observation point, how much here? This distance is going to be R plus A, is it? So it will become here R plus A whole square. Now this is the magnitude. Again if we convert into the vector form, then you can see here this is minus Q charge, electric field at point A due to minus Q charge in which direction? As charge is minus Q, that means in this direction here, towards the charge here. And you can see here I have drawn the arrow length somewhat smaller. Why? Because the distance between observation point and charge minus Q is larger compared to the distance between observation point and plus Q charge. That's why this vector is small. Now you can see this arrow and this arrow in which direction? Opposite direction. So what we have to write here? We have to write here the minus P cap, and now this one here, vector form here. Okay. Now the third will be there, resultant electric field at point A is given by, resultant electric field at point A is given by EA equal to, by the principle of superposition, we will add both of them. So E plus Q plus E minus Q. No? So you can see what other things are very common in this. We will just note down here. And this 1 by 4 pi epsilon naught, I will just write K. No? So what we can write here? See please here. K into Q. And it will become here 1 by R minus A whole square, and minus, because of this minus, R plus A whole square, and here P cap, is it? Now after that we'll simplify this here. So it will become here, when you will simplify this by using the formula A minus B whole square, A plus B whole square, so it will come here 4AR, and this will come here R square minus A square whole square, and here P cap, is it? So up to this is okay. Now let me go to the next page here. No, so see, so now electric field now at point A is given by here. Again I will write the expression here, K into Q 4AR R square minus A square whole square, and here P cap. Now we will just rearrange it somewhat. So what this will become here? See please here, K, and here it will become here 2AQ, and here also 2, and into R P cap by R square minus A square whole square, is it, students? Now after that what we can write here? K into 2. What is 2AQ? This is P. Now what is 2AQ? P into R. And what will happen that here, if we will write 2AQ and P cap together, then what we can write here? This will become here vector P by R square minus A square whole square. Very simple, basic mathematics are there. Okay, so this is the what we tell exact expression of the electric field on the axis of the dipole. Again I am writing here so that you should not get confused. Now see here, I am writing here this vector P is a 2AQ P cap, or we can tell magnitude and direction, like this here. This is the thing is there. Now after that, if we do for the short dipole, which dipole? Short dipole. So see here please now for short dipole. So for short dipole, what will happen, students? Just think and tell. For short dipole, For short dipole. So for short dipole, what will happen, students? Here, just go to the back one here. This distance small r will be very large compared to this distance small a is there. Now that's why what will happen that here, that is called which dipole? Short dipole, because before itself I have told you distance between the two charges should be small. Okay, students. So see here, please, here what will happen? This r should be greater than a. That means this r square minus a square will be approximately, what is this? R square here. Now we'll just note down here. So electric field due to short dipole will be what here? See, please, here k into 2 vector pr, and it will become here r to the power 4. Then it will be cancelled out, and what this will come here? Electric field at point A is given by k into 2p by r cube. Okay, and after that, if I write the magnitude, what I'm writing? If I'm writing the magnitude. So what will be the magnitude? What is the magnitude? Magnitude is given by E equal to k into 2p by r cube. This is the magnitude. So remember that here, for the short dipole, which one? For the short dipole, electric field on the axis is inversely proportional to r cube. Now, and due to the point charge, what was the electric field formula? 1 by 4 pi epsilon naught into q by r square. So due to the point charge, inversely proportional to r square, but due to dipole, inversely proportional to r cube. Okay, you have to remember this. Directly they will ask in an exam. Normal point charge means inversely proportional to r square electric field, but due to dipole, inversely proportional to r cube. Is it? I hope so. You are understanding it very easily now, because the topic is very easy. You have to only give the little bit attention. That's it. ठीक है? समझ में आ रहा है? Good. So now next one is, students, here please. At a point on the equatorial line of the dipole here. Equatorial line. Before that on the axis, but now we are on the equatorial line is there. So here please, here first we have to understand what is the equatorial line. Yes, here please. This is minus q charge. This is plus q charge. Let me decrease it somewhat and let me change the color. So see here please. Now this is the, what is there? The center of the dipole, and you know very well this distance is, this distance how much? This distance is a, and this distance is how much? This distance is also a. Now we have to take the point where? On the equatorial point. That means here, somewhere here I have taken here this point. Now this point, let's take, I have taken B, equatorial point B. Okay, so now this is the center, this is the observation point, this distance is called r. After that, what we'll do here, we have to calculate the electric field. Electric field at point B due to minus q and plus q charge. So first see, due to the plus q charge here. So as the electric field is the which kind? Following central concept. Now, so due to plus q charge, electric field in which direction? This direction here. I will write here E plus q. Similarly, due to minus q charge, again draw here the dotted line here. Central concept, and now this will be towards the charge here. This is towards the charge, and what is this? This is the E minus q. Now if we see both the triangles are identical. That means if this angle is theta, this angle is also theta. Draw the one dotted line here like this here. No? So if this angle is theta, what about this angle? Theta. Now can we resolve the velocities? Yes, not velocities, electric field. No? So can we resolve the electric field here? Because normally we used to resolve the velocities, so it is coming from the mouth, but okay, this one here. So this side component how much here? E minus q and sine theta here, and this side of component how much here? E minus q cos theta. Now here we have resolved the electric field. Now again this one due to plus q charge, this angle theta. So what about this angle? This angle is also theta here, and this one, this side component how much here? This side component will be, let me change the color please. This side of component will be E plus q sine theta. Okay, and this side again one more component, it will come here what? E plus q cos theta. So you can see very well E plus q sine theta and E minus sine theta will cancel out, and which components will add up? These two components will add up here. Now, so we have understood the concept very well. Now we have to just write down the mathematical thing. So again we will write here, like electric field at point B due to plus q charge is given by E plus q is equal to k into magnitude of the charge, and distance between the plus q and point B how much here? This is a, this is r. That means this distance square root of r square plus a square. So here we will write here this one here, square root of r square plus a square whole square. That means what it will become here, k into q by r square plus a square. After that, second one, similarly electric field at point B due to minus q charge is given by again k charge and here square root of r square plus a square whole square. That means again we'll simplify this. What this will come here, kq by r square plus a square. You can see very well now both are same. That means what we can write here, we can write here both are same only now. So let's take, I have taken this is E, so this is also how much, this is also E. Now third one we'll write here, by symmetry vertical components of the electric field will cancel out and the horizontal components of the electric field will add up, and hence resultant electric field at point B is given by, we'll write here, EB is equal to E plus Q cos theta plus E minus Q cos theta. Now, and you know very well E plus Q, E minus Q both are same. That means we can write here this is 2E cos theta. Now let's put the values. This is 2. Electric field value how much here? See please. KQ by R square plus A square, and this cos theta value. Can you see the triangle here? This triangle O plus Q and B. So in this triangle, what is the cos theta? Cos theta means base by hypotenuse. So base is A, hypotenuse is this one. So we can write here A by square root of R square plus A square. Now, so we'll write here A by square root means power half. We'll write here now. Then again we'll simplify this. So after simplification, what will happen? K into 2AQ by R square plus A square power 3 by 2. That means the resultant electric field for the normal dipole, no, not a short dipole. So EB is equal to K into P. Correct na? This is K into P by here R square plus A square power 3 by 2. This is the expression due to the dipole where on the equatorial point. After that, if I write for the short dipole, which one? For short dipole. For a short dipole. For a short dipole. Again, same story. R is greater than A. That means what will happen at here? In this situation, R is greater than A. That means if I write here this one here, R square plus A square will be approximately how much? This will be R square. And what we know? We have to get what? We have to get this one here. R square plus A square power 3 by 2. That means it will become here R square power 3 by 2. And it will become here what? R cube. Hence electric field. And hence electric field at point B is again K into P by what was that? R square plus A square power 3 by 2. That means it will become here electric field at point B is K into P by R cube. Now this is the electric field magnitude. Here the magnitude is enough. After that we know very well on the axis was how much? This is on the equatorial point, and on axis what was the formula? The formula was EA is equal to K into 2P by R cube. This was on the axis, and this is where? On the equatorial point. Now if we write the comparison, so what is this? Electric field on the axis and electric field on the equatorial point. How much ratio will come? 2. Please remember that here. Okay. After that, now you have to understand the angle concept also. Now, just let me go to here, please. On the axis, angle concept. What they will ask in a question, please remember that here. They will ask angle between electric field and the dipole moment. So, see here, please. Here again, I'm writing here. See here. The dipole moment in this direction here. Vector P, and electric field at point A in this direction is there, EA. That means here in this situation, dipole moment and electric field will make how much angle? The angle between dipole moment and the electric field will be 0 degree here in this situation. Is it? Now if we go for the equatorial point is there, equatorial point. Here in this situation, see please, in this situation, dipole moment in which direction? This direction. Is it? P. Dipole moment in this direction, P. Electric field in this direction, electric field in this direction, electric field in this direction. How much? EB. You can see that both the arrows in which direction? Opposite direction, opposite direction. That means if I want to write in a vector form, that means in vector form, in vector form, electric field at point B will be how much here? K into P by R cube, and here I have to multiply minus P cap, because which direction? Opposite direction. That means in a vector form, electric field at point P will be how much here? K vector P, and here itself you can put minus by R cube here. So now can you get very well? Electric field and the dipole moment is making how much angle? They are making how much angle here, please? Here, this vector P and B is making how much angle? Please remember that here, this angle is used to be 180 degree. In case of the electric field on the axis, 0 degree. In case of electric field on the equatorial point, they will make how much angle? 180 degree. That's why in a vector form on the axis, K into 2P by R cube. But on the equatorial point, K into minus P by R cube for the short dipole. Is it? So we have seen electric field on the axis and on the equatorial point. Now one more concept is there, very easy, and that is the at any general point. Sometimes they used to ask that. So see here, please here. Now here again, here charge is minus Q and here charge is plus Q, and this point O is there. No? Very easy. Now what I will do here, I will take here some general point is there here. This is the general point. Let's take, I have taken point P. Okay. So, and the direction of the dipole moment is which side here? The direction of the dipole moment is this side. This is the dipole moment direction, and this is the which vector? This is the position vector. Even we can tell like this also. Which vector? Position vector R, and they are making how much angle? Theta. Okay. So what will happen that here, if I want to resolve here the components here, components. So see here, please here. For this dipole, this side component how much? This side component how much here? P cos theta, and this side component how much here? Component. This side of component how much here? P sin theta. So you can see very well, point P is on the axis of P cos theta, but point P is on the equatorial point of P sin theta. That means electric field at point P due to P cos theta component in which direction? This direction. This is called component E parallel. Okay, due to this P cos theta. Okay. Similarly, electric field at point P due to this P sin theta component in which direction? As I told, how much angle? 180 degree angle. So this will be E perpendicular here. Okay. Now students, if I write here the value, so E parallel is the on the axis. So formula K into how much? Dipole moment P cos theta. So K into P cos theta by R cube. Similarly, after that, if I write here E perpendicular component now on the equatorial point due to which one? P sin theta. That means it will become here K into P sin theta by R cube. See, I have done one mistake. Now, this 2 I have not written on the axis. We have to write 2 also. Is it? Now, after that, if I want to know the resultant electric field at point P, so draw here the parallelogram like this. This is the resultant electric field EP. Na? And let's take this angle is alpha. So, by the parallelogram method, you know very well, electric field at point P is given by E parallel square plus E perpendicular square. When you will put the values and all that, it will come K into P by R cube square root of 1 plus 3 cos square theta. This is the electric field at point P. Okay. Now, if we go for the axial point, that means theta how much here? Just guess please. Axial point theta will be 0 degree because point P will come where? This point P will come here at point A, and what will happen? This angle theta will become 0 degree. Similarly, equatorial point. Which point? Equatorial point. Theta will be how much here? 90 degree because this point P will come and it will shift here. Now equatorial point is there. Now, so please remember that here. So for theta equal to 0 degree, it will come K into 2P by R cube. For theta equal to 90 degree, it will come K into P by R cube. Is it? Now after that, if we talk about the direction, now here some space is there. Now let me talk for the direction. Direction. Can you get the tan alpha? Tan alpha. What is the tan alpha? Opposite by this one here, opposite by adjacent. So we can write here tan alpha E perpendicular by E parallel. Now, so when we'll do here E perpendicular by E parallel, it will come here tan alpha is equal to half tan theta. This is the relation. Okay. So students, now we have reached to the end of the topic. So in this today's class, what we have learned? In this today's class, we have learned electric dipole, their important points, dipole moment and electric field at axial point, equatorial point, and the general expression also. Is it, students? So just comment, share and subscribe to my channel. Thank you so much. Keep loving me and keep watching my videos. Thank you so much.